my name is Mohammad Shazam Shukri. Our group has chosen properties of relation as a group project title. So, before we get started, let me briefly explain to you what is a relation. So, relation is a discrete mathematics play an important role in many computational and logical procedures. A relation is a collection of ordered pairs that specify how items in set are related. Understanding these features, reflexivity, symmetry, and transitivity allow for more effective algorithm creation and optimization in computing. These features are critical in areas like database, administration, graph theory, and artificial intelligence.
My name is Muhammad Faris Muhammad Indra. Today I will explain about problem statement and objective for relation of properties. First, we go to the problem statement. Firstly, we have an identification of properties, which is given a relation as a set of ordered pair checks, which is a relative, symmetric, antisymmetric, and transitive. Secondly, we have a classification of relation to determine if a real number is equivalent relation, if it is a relative, symmetric, and transitive, and it is a partial order if it is a relative, antisymmetric, and transitive. Lastly, for a problem statement is a closure computation. If a real number does not satisfy certain properties, find the smallest modification to make it a relative, symmetric, and transitive, while preserving as much of an original structure as possible. Next, we move to objective. Firstly, we have a criticizing relation to determine whenever a relation possesses key properties such as relativity, symmetry, transitivity, antisymmetry. Next is classification relation to identify whenever a relation is equivalent relation, a partial order or strict order based on its properties. Lastly, constructing closure is to finding the relative, symmetric, or transitive closure of a relation to extend it in a meaningfully way.
My name is Muhammad Ilhan bin Muhammad Shabri, and I will explain the pseudo code. First, initialize a set of elements and initialize a set of relation. Then, set elements equal to elements we entered, and set relation equal to relation we entered. Next, check if the pair element exists in the relation. If the pair is not found, return false. If yes, return true. Then check if the reverse pair, second and first, exists in the relation. If the reverse pair is not found, return false. If yes, return true. Then check if the pair first and first, pair 2 and second exists in relation. If the pair is not found, return false. If yes, return true. Next, create a new set of pairs called closure. Start with the existing relation, then we add the pair element to closure, return closure, and then create a new set of pair called closure. Start with the existing relations, add the reverse pair, second and first, to closure, return closure, and then we create a new set of pair called closure. Start with the existing relations, set change to true while change is true, set change to false for each pair first in closure, for each pair 2 in closure. If the pair second elements equal pairs 2 first element, add the pair first dot first, pair second dot second to closure, set change to true, return closure. Display the result of reflexive, is symmetric, and is transitive. Display the closure, reflexive, symmetric, transitive. For compare the pair, we start with initialize first and second element as character. Then we set first equal to first we entered, and then set second equal to second we entered. If first equal other dot first and second equal others dot second, return true, else return false. Then return a unique hash code based on the first and second elements. Next, return the string representation of the pair in the format first, second, and then.
So, Assalamualaikum. My name is Ifran bin Idris, and I will be explaining on how the code works. So my code is it will determine whether a set of pair of elements is a relation or not. So first of all, we have two classes, one for the calculations and the comparison, and another for the UI. So the first class, first of all, we're going to declare the class, which is relation properties. So we have elements, which is the elements in a set, and the relations, the pairs of set that will be inserted into the coding. So first of all, the code will check whether if the pair of the pairs in said set is reflexive or not. So it will compare if there is any instance of that both of the pairs are not the same of each other. So if it's not the same, for example, 1 1 in a set of 1 2 3, 3 3 is not available, and it will detect that 3 3 is not there, and it will return false. So secondly, it will detect is it symmetric. So let's say we have 1 2 and 2 1. If it detects the presence of 1 2 and 2 1, it will return true, because in the if column is, say, it detects if it is not available there. And next we will check whether it is transitive or not. And from the transitivity, if it detect that it is not inside the set of data, then it will return false, and if it's available, then it will return it true. So, and then we will have uh the sets, the classes that will return the closure of said uh elements of data. So let's say if the reflexivity is false, it will retain the closure of the reflexive, which will in turn complete said data for it to be equivalent. So this is for reflexive closure, symmetric closure, and transitive closure. So this is the main class. It will run all said classes above to detect its equivalency. Okay, classes, the characters, the second. So in the class pair, it will determine each set as a pair. So we have a first character and a second character, and it will compare between the two. And this is the coding for this GUI. As we can see, JFrame in which it will display asking for users its input, relation properties checker, some text that gives instruction on how users to use it, some examples on how to enter, and it will run if we press the check properties button. So I will proceed with the demonstration of the code. So let's try. So, so as you can see, the window has appeared, and it will check the relation. So first of all, we must enter the elements of the data. So let's say the element is 1 2 3 4. So let's try with something simple that will display true for all of the reflexivity, symmetry, and transitivity. So let's try 1 1 2 2 3 3, and 4 4. As you can see, it returns it as true because it is reflexive, symmetric, and transitive. And since all of it is true, its closure is there is nothing new in the closure. So let us try if there is a false statement. Let's say it is not symmetric. So let's put 2 1, 2 2, 3 3, and 4 4. Since there is 2 1 but no 1 2, we can detect that it is not symmetric. So as you can see, it's reflexive, symmetric, and transitive. And in the closure, it completes to 1 by including its symmetrical pair 1 2. So that is all. Thank you.
To conclude, this project has the potential to be expanded by integrating more connection qualities like anti-symmetry and equivalence. Another addition may be incorporating a graphical user interface (GUI) to make the system more interactive and user-friendly. Further research can be conducted on optimizing the algorithm for handling larger dataset efficiently, making it suitable for real-world applications like network analysis, decision system, and database query optimization.